I think everything is okay now. Sorry for the disturbance and sorry for the network issues. Okay, we'll start with the chapter. Light is a form of energy, and then we want to know about the properties of light. What are the properties of light? Electromagnetic wave. Light is also known as electromagnetic wave because it consists of both electric field and magnetic field. And then light travels in a straight line. Next, what is the speed of light? The speed of the light is maximum in vacuum. The value is 3 into 10 power 8 meter per second. Okay, when we are talking about light, what happens in light? When a light falls on the surface, what will happen? There are three possibilities. One is reflection, refraction, and then absorption. These are the three possibilities which can happen when a ray of light falls on the surface. Okay, I will repeat it again. The main points you should remember are what is meant by a light. Light is a source of energy or a form of energy. Okay. The second point, it is an electromagnetic wave. So it consists of both electric field and then magnetic field. The third point is it travels in a straight line. Fourth point, the speed of the light is maximum in vacuum. So the value is 3 into 10 power 8 meter per second. What happens when a ray of light falls on the surface? Reflection, refraction, absorption. These three will take place. We are not going to talk about absorption. We are just going to learn about reflection and refraction on a surface. Okay. Now, what is meant by reflection? Bouncing back of light is known as reflection. Let us consider a polished surface or a smooth surface like a mirror or a tiles. For example, I'm just going to throw a ball on the polished surface. What will happen? Bouncing of ball takes place. Like that, when a ray of light falls on the surface of the smooth surface, what will happen? Bouncing of light takes place. So, when we are talking about that, we should know about the laws of reflection. What are the laws of reflection? The angle of incidence is equal to the angle of reflection. So angle I is equal to angle R. Angle of incidence is equal to the angle of reflection. So what is the second point? The incident ray, the reflected ray and the normal at the point of incidence all lies in the same plane. Okay, forget about these points. I will just give you some hints how to write it. Okay, now please look at this diagram. This ray represents the incident ray. Okay, this pink color line represents the normal, and then this line is called as the reflected ray. Okay, so incident ray, the normal, reflected ray lies on the same plane. That's all. This is what reflection means. Okay, and then here, for example, this angle is 30° means this angle is also 30°. So angle of incidence is equal to angle of reflection. That's all. So this is the laws of reflection. What is by reflection? Bouncing back of light is known as reflection. Is it understandable? Can you please put thumbs up in the chat? Okay. Okay, Adam. Thanks, Adam. Thanks, Yogesh. Thanks, Zoya. Thanks, Shazia Masood. Okay, we'll start with the next one. Now we are going to the image formed by a plane mirror. What is my plane mirror? When we go for mirror, there are two types. One is plane mirror, next one is a spherical mirror. So, what are the types of mirror? This may be a question in your board exam. What are the types of mirror? There are two types of mirror. One will be plane mirror as usual, which we are using it in the bathroom and in other rooms for seeing it. Okay. So what are the types of mirror? Plane mirror. The next one is spherical mirror. Okay. Now we'll go for the image formed by a plane mirror. Okay, let us consider this line as a plane mirror and then this A to B as the object. Okay, first everyone should remember this one. When we are talking about the mirror, the object is always placed at the left hand side of the mirror. Okay, so A to B represents the object. So let us see here this distance, the distance from the mirror to the object. Let us consider this as u. Now the image is formed in the mirror, so it can be called as a dash b dash. Okay, so the distance from the mirror and the image is v. So what is the distance from the mirror and object? It is u. What is the distance from the mirror and image? It is v. So distance, or to be simple, object distance is u, image distance is v. That's all. Remember in your mind. Okay, now we are moving to the characteristics of image. Before that, you want to know something. What is the distance between the mirror and the object is equal to the distance between the image and the mirror. So here the object distance is equal to the image distance. So u is equal to v. When it happens, it only happens in the plane mirror. Okay, now characteristics of image. When we are talking about the characteristics of image, you should know something. Virtual and erect. What is meant by virtual image and what is meant by erect? If you know the meaning of virtual and erect, please mention it in the comment. Next, size of the image is equal to the size of the object. Yes, it is true. So here let us consider this will be 2 cm. So the image formed by the mirror is also 2 cm. So the distance between the mirror and the object is 10 cm. Means what is the distance between the image and the mirror? What is the distance between the image and the mirror? Please mention it in the comment board. Next point. Image is formed as far behind the mirror as the object is front of it. Yes. Let us consider this as the mirror. So the object is kept here. The object is kept here. So the image will be formed in the mirror. So the distance between the mirror and the object is equal to the distance between the mirror and the image. Oh, okay. Now, so we can directly say that u is equal to v. What is the meaning of laterally inverted? What is meant by lateral? Lateral inversion means right side of the object appears left side of the image, vice versa. For example, when you are entering your restroom or when you are entering your closet or something else, means we are going to see ourselves. So we are going to see the reflection of ourselves in the mirror. So when I'm going to raise my left hand, means I'm going to see that my right hand will be raised there. When I'm going to raise my right hand, means I'm going to see that my left hand will be raised there. Am I right? Like that. Now we are moving to the spherical mirrors. Can you please say that whether everything is okay within the plane mirror? Okay, now when we are talking about the mirror, I already said that there are two types of mirror. One is concave mirror, another one is convex mirror. Okay, when we are going to talk about concave mirror, we should know that what is meant by a concave mirror. A concave mirror is nothing but it is a spherical mirror which is curved inwards. Concave means curved inwards. It is like a spoon. Spoon is a great example for a concave mirror. If you are sitting in the room, means go to your kitchen, take a spoon and see yourself on the spoon. You can able to see that your image will be inverted. You can able to see yourself inverted, but the real image will be formed. Okay. Only few are there. Can you please call your friends, ask them to join the session? After the completion of physics, we'll go to the biology, okay? Thank you, Yogesh. Thank you, Zoya. Thank you, Shasya ma'am. Okay, now we'll start with concave mirror. There are two types of spherical mirrors. One is concave mirror, the next one is convex mirror. What is the meaning of concave mirror? When a spherical mirror is curved inwards, this is a spherical mirror. Here we can able to see that the mirror is curved inwards. So this blue line indicates the arch surface and this sky blue line indicates the reflecting surface of the mirror. So when a mirror is curved inwards, this is known as concave mirror. Okay. Now, what is my convex mirror? The reflecting surface of the mirror is curved outwards. So please keep it in your mind, when the mirror is curved inwards means it is a concave mirror. When the mirror is curved outwards means it is a convex mirror. Okay, don't make it too serious or too confusing. Okay, to be simple or to be clear, the mirror which is curved inwards is known as concave. CC concave, curved inwards. Okay. Now, when the mirror is curved outwards means it is a convex mirror. The reflecting surface is curved outwards. Okay. Now, please listen here. Now we are moving to the next point here. Please listen here. This point, this is a concave mirror. This point, this line represents the principal axis and this point represents the pole. And this point is called as the focus, not focal length. This point is called as focus. And then this 2F can be also represented as capital C. Capital C means center of curvature. Okay, I will say it again. I will repeat it again. This is a concave mirror. This is a concave mirror. This line represents the principal axis and this point is the pole. Okay, this point is called as focus, not focal length. And this 2F represents the center of curvature C. Okay, the same will be happening in the convex mirror. This line represents the principal axis and this point, center point of a curved mirror or spherical mirror, is called as pole. Okay, this point is called as pole and this point is called as focus and this point is called as 2F. Here 2F represents the center of curvature. Okay, now listen carefully. From the pole to focus there is a distance. This distance is called as focal length, 1F. And then from focus to center of curvature there is a distance, right? This distance is also called as focal length. So what is the focal length now? I can able to say that this point to this point, from the pole to center of curvature there will be a distance. This point is called as radius of curvature. So I can able to say that 1 time of focal length plus 2 time of focal length is equal to radius of curvature, so that we can able to write it as capital R is equal to 2F. So 2 times of focal length. Don't be confused, I will say it again. This point is called as pole. This center point is called as pole. This point is focus and this point is center of curvature. So pole to focus, this point is called as the focal length. Pole to focus, 1 focal length. Focus to center of curvature, another focal length. So how many focal length are there? 2 focal length are there. So we can write it as 2F. So next point is from the pole to center of curvature, it is called as radius of curvature. Radius of curvature. So this distance is equal to capital R. So one focal length, two focal length. Instead of writing capital R, we can able to write it as two focal length. So capital R is equal to 2 times of focal length. That's why I mentioned here. Okay. So again, I will repeat the points. This line represents the principal axis, and this point is the pole. This point is the focus, and this point is the center of curvature. Okay. Next, from the point pole to focus is called as one focal length, and the point focus to center of curvature another focal length. So how many focal length are there? Two focal length are there. So instead of writing capital R, we can able to mention it as R is equal to 2 focal length. Okay. Now we are moving for the ray diagrams. This is not that much important for your upcoming exam, but please make sure that you are good in studying these ray diagrams. Okay. After the session, I will post every notes in this YouTube link. Okay. You can download it through the Telegram link. Okay. Next. Now listen here. This ray diagrams. There are 4 ray diagrams which you want to be thorough. Okay. You should be thorough in this 4 ray diagrams. Okay. We'll start with the first one. A ray parallel to the principal axis will pass through the focus after reflection. Nothing we can able to understand, right? To be simple, let us consider this as a concave mirror, and then this point is also known as principal axis, this pole, focus, center of curvature. Okay, when a ray of light parallel to the principal axis, it gets strike the reflecting surface of a concave mirror, and then what will happen? Take U-turn. If the road is jammed, if the road is under maintenance, means what the police will take U-turn, take U-turn. Yes, the same thing will happen here. When a ray of light falls on the surface, reflecting surface of the mirror, what will happen? Reflection will take place. So this will be the incident ray and this will be the reflected ray. So when a ray of light parallel to the incident ray, when a ray of light parallel to the principal axis, what will happen? It comes back through the focus. The same will be happening here. Okay. So we'll go for the next rule. Rule number 2. Opposite to the rule number 1 is rule number 2. Okay. When a ray of light passes through the focus, comes back as a parallel line. Okay. When a ray of light passes through the focus, comes back as a parallel line. I think everyone can able to understand, right? If it is understandable means, please mention it in the comment part. Yes, the rules always remain same in all the cases. Okay, there will be no change in the rules. What is meant by rules? If some rule is given in the school, means we are going to follow, right? For example, students should wear uniforms properly. Means we are wearing uniform. That's all. Like that, these rules are compulsory to be followed. Okay. Now please listen here. We are moving to the third ray diagram. This is very simple. Now a ray passing through the center of curvature means it directly gets hit on the or it directly gets strike on the reflecting surface of the mirror, and then it comes back through the same path. This arrow mark represents the incident light falling on the mirror, and this arrow mark represents the reflecting light coming from the mirror. This light falling on the mirror, after the reflection, again it come back through the same path. Okay, this is the third rule. Next, fourth rule. What is happening in the fourth rule? Let us consider this as a straight line. So it represents the law of reflection. When a ray of light falls on the reflecting surface, what will happen? reflection takes place. So when a ray of light falls on the pole, it will be reflected in the same path. So angle I is equal to angle R. That's all. This is what fourth rule represents. Okay. Now we are moving to the case studies. I think these case studies are too simple. I will post it in the group. After the completion of physics, we are going to the biology topic, life process. Okay. So please listen here carefully. What are the case studies? Now, here the position of the object is at infinity. We will go in the fast forward session. Okay. I'm going to place the object here. So what is happening here? There will be, please keep this in your mind. When I'm going to keep an object here means we can able to say that there will be two lines coming from the object. One will be from the top and one will be from the bottom. If the object is kept at the top means everything will be from the top. Okay. All the two lines will be coming from the top. Now listen here. This is the object. When a ray of light falls on the surface, or this ray of light looks like the first rule. What will happen in the first rule? When a ray of light parallel to the principal axis, it comes back through the focus. So it falls on the focus. That's all. Next. Again the same will happen here. When a ray of light falls on the reflecting surface, what will happen? It passes through the focus. So all the lights are meeting at one point, which is called as focus. So where will the image will be formed? Image will be formed at the focus. Okay. So now the size of the image, it is highly diminished or point sized. Point size means now both the points are meeting at one point. So it will be very small in size. When compared to the object, the size of the image will be very small in size. Okay. Nature of the image will be real and inverted. So please keep it in your mind. When we are going to talk about the concave mirror, the nature of the image will be always real and inverted. It will be always real and inverted. When we are talking about the convex mirror means it is virtual and erect. Okay. Take your notebook, start making a note of these points. Okay. Nature of the image of a concave mirror means real and inverted. Nature of the image formed by a convex mirror means virtual and erect. Okay. Now I think you can able to understand the case studies. We'll directly go to the next points. Now, what are the uses of concave mirror? Don't worry, I will post this entire thing in the WhatsApp group. There will be a separate channel will be followed. Okay. Separate WhatsApp group channel, telecast channel, broadcast channel will be followed. Please follow the channel. You can get all the notes from there. Okay. Now listen here carefully. We are moving to the uses of concave mirror. What are the uses of concave mirror? Torch, searchlights, vehicle headlights. Why we are using these types of things as a concave mirror? See how the vehicle headlights looks like. We are going to remove the structure. So this bowl-like structure represents the concave mirror. Okay. So torchlight, searchlight, and vehicle headlights are the great example for this one. Okay. Shaving mirror, dentist mirror, solar furnaces. These are the things which we are using for concave mirror. Okay. Concave mirror are used in these applications. Okay. What is the image formed by a concave mirror? It will be real and inverted. But in special case, when we are going to keep the object between the P and F, what is meant by P? P is the pole, F is the focus. So it will be formed beyond the mirror. So the size of the image will be enlarged. So the nature of the image will be virtual and erect. Okay. So there is no error in this, I think. So please listen here. The nature of the image found by a concave mirror is real and inverted. Okay. And then concave mirror is also known as converging mirror. Now we are moving to the convex mirror. Uses of convex mirror. Rear view mirrors in the vehicles. What are the rear view mirrors in the vehicles? For example, let us consider a bike. In that bike mirror, you can able to see some quotes or words. Object appear closer when they appear near. Object appear bigger or smaller when they appear. Am I right? These are the things will be written on the mirror. Why they have written it? These are the examples for convex mirror. What is meant by convex mirror? It is a diverging mirror. Convex mirror is a diverging mirror. Okay. Now please listen here. We are moving to the sign convention. Okay. Yes, Jane. After this biology class, I will take chemistry. Okay. So one session will be 30 minutes. For physics 30 minutes, biology 30 minutes, and chemistry 30 minutes. Total 1.5 hours. Okay. Okay, now please listen here. This is the most important concept or most important topic, sign convention. What are the things you are going to learn from this topic? Let us consider this as a concave mirror. This M and N. Please look at this M and N. The same thing you are going to learn in lens, but it will be called as aperture of the lens. Okay, this M and N represents the aperture of the lens, not in mirror. Okay, we are not going to use M and N in the mirror now. Okay, now what are the things which you should remember when we are going to talk about sign convention of the mirror? Okay, now what are the things? First thing, the object will be always kept at the left hand side of the mirror. Okay, so what is the sign of the object? It will be always negative. The sign of the all object will be always negative. When we are going to solve numerical problems means, for example, in your numerical problem, the object distance is 10 centimeter means you want to write it as u is equal to minus 10 centimeter. So they are going to mention u is equal to minus 10 centimeter means you want to mention it as minus 10 centimeter because they are already given in the question itself, right? No need of changing it. Okay. So what is the value of u? U is always negative. U is equal to minus value. Okay. Next, where will be the image formed? If the image is formed at the top means it will be positive. If the image formed at the top means it will be positive. If the image formed at the downwards means it will be negative. Okay. Now please listen here. The important key points from this topic is object distance, it will be u. It is always kept at the left hand side of the mirror. It is always negative. Focal length of a concave mirror is always negative. Focal length of a convex mirror is always positive. These are the key points you should remember. Okay. Now we are moving to the next topic called mirror formula. 1 by v is equal to 1 by v plus 1 by u is equal to 1 by f. Here f is the focal length, v is the image distance, u is the object distance. What is v? V is the image distance, u is the object distance. What is meant by f? F is the focal length of the mirror. Okay. Now we are going to solve some numerical problems based on this topic. Okay. After the entire session we are going to solve numericals. Okay. Now listen here. What is magnification of spherical mirrors? When we are going to talk about the magnification of spherical mirrors, what are the things you should remember? We should remember two things. One is the formula and the next one is these are the key points. When the magnification is real, when the image formed is real means the magnification is negative. When the image formed is virtual means the magnification is positive. These are the key points you should remember. What are the key points you should remember? First one, concave mirror is a converging mirror. Convex mirror is a diverging mirror. Focal length of a concave mirror is negative. Focal length of a convex mirror is positive. Okay. The image formed by a concave mirror is real and inverted. The image formed by a convex mirror is virtual and erect. These are the key points you should remember. Okay. Next, if M is negative, the image is real. If M is positive, the image is virtual. Okay. Only 7 are there in the group. Please make a call to your friends. Call your friends to join the session. Ask your friends to join the session. Please tell to grade 10th C to join the session. Call your friends, call your colleagues, ask them to join the session. After physics, we are going to start biology. After that, chemistry. Okay, till this, if you have any doubt, you can ask. We have completed till the mirrors. Good evening, Ayan. Call your friends to join the session. Okay, till this topic, do you have any doubts? You can put your doubts in the comment box. I will reply. If you have any doubts, please put it in the comment box. If you have any queries, please put it in the comment box. After this, we'll move to the biology topic. After that, last chemistry. Okay. Ask your doubts. Yes. No doubts. What is your doubt? Yes. What is your doubt? Okay, good question. Light which is incident on the mirror is positive or negative? Light which is incident on the mirror is positive or negative? A good question. Okay. So we'll go for the ray diagrams. You'll get the answer. Okay, now tell me. This is the object is kept here, right? So what is the sign of the object? It will be negative. Okay. So the negative sign will be directly placed on the mirror. So what is the incident ray now? Incident light is from the object. The object is always negative. So incident light falling on the mirror is negative. That's all. Is there any other doubts? Shall we start the session? Shall we start refraction? Yes means please put yes. Okay, we'll start the session. Refraction of light. What is meant by refraction of light? Before that, we have completed reflection of light. Okay, now we are going to move to the next topic called refraction of light, the phenomenon of change in the direction of the light when it passes from one transparent medium to another transparent medium. It is not understandable, right? It is in different words. To be simple, what is the refraction of light? Bending of light is known as refraction of light. Okay, now listen here. Let us consider this as medium 1 and this will be medium 2. Medium 1 and medium 2, let us consider this medium 1 as rarer medium and medium 2 the denser medium. Okay, so when a ray of light falls on the surface, what will happen in reflection? In reflection, bouncing back of light will take place. Okay, but here it is not going to happen. Okay, when a ray of light falls on the surface, there will be a bending takes place. It is not a straight line. This is a rarer medium and this will be the denser medium. So when a ray of light falls on the surface, when a ray of light travels from one medium to another medium, bending of light will take place. When a ray of light travels from rarer to denser means it bends towards the normal. This point is called as normal. It is bending towards the normal. Okay, when a ray of light passes from denser medium, this will be the denser medium. When a ray of light passes from denser medium to rarer medium, it is goes away from the normal. To be simple, keep it in your mind. Rarer to denser means it bends towards the normal. Denser to rarer means it bends away from the normal. Okay, rarer to denser bends towards the normal. Denser to rarer bends away from the normal. Okay, this is called as refraction of light. Okay, what is meant by refraction of light? Bending of light is called as refraction of light. Okay, when we are going to talk about this, we should know about the mediums. One medium will be rarer medium and another medium will be denser medium. What is the example for rarer medium? When we are going to talk about rarer medium, air and vacuum are the great example for rarer medium. When we are going to talk about denser medium, we can able to see a lot of examples like glass, water, liquid items, ruby, diamond. These are the examples for denser medium. I will repeat it again. When a ray of light travels from rarer to denser means it bends towards the normal. The distance between this ray and the normal is very low, so that we can able to say that it bends towards the normal. Remember in your mind, it may be a 1 mark question in your board exam. Okay, now the next one, this point represents the normal. When a ray of light travels from denser to rarer means it bends away from the normal. Now measure the distance from here to here and here to here. We can able to say that this is away and this is near. Okay, towards. I think everyone can able to understand, right? Now we are moving to the laws of refraction of light. What are the laws of refraction of light? We should know about this angle. Sin I divided by sin R is equal to constant. This formula represents the Snell's law of refraction. Sin I. What is my sin I? Sine of the angle of incidence divided by sine of the angle of refraction is called as Snell's law. Okay, the first point, incident ray. From this diagram, we can able to see that. Let us consider this as a transparent medium. Incident light, refracted light, and normal lies on a transparent medium. That's all. Okay. To be simple, incident ray, normal, refracted ray lies on the same transparent media. This is the first point. Okay. Second point, sin I divided by sin R. This is sin I, this is sin R. Sine of the angle of incidence divided by sine of the angle of refraction. So sin I divided by sin R is equal to constant. Snell's law of refraction. So refractive index is equal to n is equal to, forget everything, just remember this formula. N represents the refractive index of the prism, refractive index of the medium, everything we can able to say that. Okay, now how the question will be asked, find the refractive index. They will give the value of C, they will give the value of V. We want to find the value of N. Okay, or else they will give you the value of N, they will give you the value of V. You want to find the value of C. How to find the value of C? We know N is equal to C by V, so we don't know the value of C. We know the value of N, we know the value of V. So we are going to multiply by both to get the value of C. But we know the value of C. Why and how? Because C is a constant value, the speed of light in a medium, the speed of the light in air. What is the speed of light in air? C is equal to 3 into 10 power 8 meter per second, okay, or meter second power minus 1. This is the speed of light in air, okay. Now we are moving to the next one called lens, okay. What is mean by lens? When we are going to talk about lens, we should know something. It is a combination of two mirrors. We already know that. When we can able to say that this mirror is, this curve is a concave mirror and this curve is a concave mirror. When both concave mirror combine together means we will get convex mirror. Okay, so this is a convex and this is a convex. So when both are going to join means we will get a concave mirror. Okay, the combination of mirrors are known as lens. Combination of mirrors are known as lens. How many types of lens are there? There are two types of lens. One is concave and another one is convex. Okay, so mirror is directly opposite to the lens. Okay, so this convex lens is also known as converging lens. There concave lens is converging, concave mirror is converging mirror. Here convex lens is converging lens. Okay, concave, convex, concave mirror, convex lens, concave lens, convex mirror. If you don't want to be confused means take a sheet of paper, write it on the paper. Okay, concave mirror is equal to convex lens, concave lens is equal to convex mirror. I will tell it slowly, please listen carefully. Convex mirror is equal to concave mirror. Okay, convex mirror is equal to concave lens, concave mirror is equal to convex lens. That's all. Okay, now we are moving to the topics. Hello. Am I audible? Okay, thank you. We'll go to the next one. Now we are moving to the lens. First of all, we want to know what are the things present in the lens. Okay, here we already know something. This line is called as principal axis. Okay, this center point is called as. Now we want to know two different terms. This is not the pole. The center point is not the pole. Here it is called as optic center. Here it is called as optic center. Okay, now listen here carefully. This center point represents the optic center of the lens. Okay, this f1 and this f2 represents the focus of the lens, and this 2f1 and these 2f2 represents the center of curvature of a lens. Center of curvature of a lens. Instead of writing 2f1 and 2f2, I can mention it as c1 and c2. Here we want to know something. The distance between the M and N, or the height of the lens, is known as aperture of the lens. Okay, M and N. The distance between M and N is known as aperture of lens. Okay, so this point is represented as O, and this point is F1, and this point is F2. O represents the optic center, F1 and F2 represents the focus. Okay, 2f1 and 2f2 represents the center of curvature of a lens. Okay, now we are moving to the ray diagrams of lens. Okay, to be simple, there are three ray diagrams which you should remember. Okay, first ray diagram as same as the mirror. Okay, what will happen in the first ray diagram? When a ray of light parallel to the principal axis, it passes through the focus. The same will be happening here. Okay, here it is passes and falls on the focus because it is a converging lens. Okay, here when the ray of light falls on the reflecting surface of the lens, what will happen? It will directly diverge and then it gets refracted, and then it gets refracted. Refraction of the light takes place here because we are going to talk about the denser medium. This entire thing is in air medium, so it is rarer medium. This entire lens is made up of glass. It is a denser medium. Okay, when a ray of light passes parallel to the principal axis, what will happen? When a ray of light passes parallel to the principal axis, what will happen? It directly passes through the focus. Okay, this is the first one. The same will be happening in the concave lens. Okay, the next ray diagram. What is the next rule of the ray diagram? Opposite to the first ray diagram is the second. Okay, when a ray of light falls on the focus, come back as a parallel line. Easy, right? When a ray of light falls on the focus, come back as a ray of light, parallel line. Okay, now here I can able to say that this line directly goes through it. It will never come back because this center point doesn't have the principle of refraction. This doesn't have principle of refraction. Okay, now what is the refraction? Bending of light is known as refraction, right? Here when a ray of light falls on the rarer to denser, what will happen? It bends towards the normal, but here no bending takes place because we are going to pass the entire ray of light on the optic center of the lens. So when a ray of light falls on it, it will never come back. Okay, ray of light passing through the optical center of a lens. That's all. When a ray of light falls on the optic center, it will never come back. Okay, I think you are good in these three ray diagrams. We'll go to the next case studies. First case study. What is meant by converging? All the points meet at the same point is known as converging, right? When a ray of light parallel to the principal axis, it passes on the focus, pass through the focus. So where the image will be formed? Image will be formed at the focus. That's all. Finished. Easy, right? The same thing. If you know the ray diagrams, you don't want to draw the diagrams. You can directly say the answers. If you know the rules of these ray diagram, means you don't want to draw the diagrams, you can directly say the answers. Okay, I already told that a concave mirror is equal to convex lens, so both are converging. If converging takes place, the image formed will be real and inverted. If converging takes place, the image formed will be real and inverted. Okay, now second case study. What is the second case study? What is happening here? I can able to say that the rule number 1 and rule number 3 is applied here. Okay, here this light directly falls on the lens and then it gets refracted through the focus. Refracted through the focus. What is the next point? When a ray of light passing through the optic center, it never comes back. So here no refraction takes place. Okay, so this may be the refracted ray and this may be the incident ray. So when both meet each other at a single point, image will take place. So the image will be formed between F2 and 2F2. Image will be formed between F2 and 2F2. What is the nature of the image formed? It will be real and inverted. It will be real and inverted. Ritesh, thank you. I will not join next opus. I will make my channel as more than better than next opus. Okay. Okay, please listen here again. I'm just going to place my object behind. Beyond means back, far away from the center of curvature of the lens. What will happen here? Refraction will take place because we are using the lens. So we are going to use the first rule and the third rule here. When a ray of light parallel to the principal axis, it passes through the focus. And the second rule is when a ray of light passes through the optic center means it never come back. So both the rays meet at one point. So the image will be formed at that point. Okay. So it will be formed between the focus and the center of curvature. So the same will be happening here in the both the diagrams. The same will be happening here. Okay. Now we are moving to the concave lens. Okay. Now we are moving to the concave lens. What is happening in the concave lens? Diverging of light takes place. So I already told that a concave lens is equal to convex mirror. Okay. Concave lens is equal to convex mirror. What will happen? The image formed will be virtual and direct. That's all. Parallel line will be always passed on the focus. Parallel line will be always passed through the focus. Done. Finished. The same thing is happening here. Now we are moving to the lens. Okay. Uses of concave and convex lens. Uses of concave and convex lens. Now, what are the things you want to remember? Uses of convex lens. What are the uses of convex lens? They are used in the camera, focus sunlight, simple telescope, projector microscopes, and magnifying glasses. These are the real world applications where we are using the convex lens. Okay. Please keep it in your mind because it may be a one more question in your board exams. Okay. Next, we are moving to the concave lens. Where are the places where we are using concave lenses? We are using it in the glasses, spectacles, and then spy holes in the doors. Spy holes. When we are going to some other hotels or motels or restaurants, means we can able to see some spy hole doors, spy holes in the doors. Okay, these are made up of concave lens. Okay. Next, some telescopes. Binocular is a great example for concave lens. Okay. Now, the most important point we are going to see about lens formula. The opposite to the mirror formula is lens formula. 1 by V plus 1 by U is equal to 1 by F means mirror formula. 1 by V minus 1 by U is equal to 1 by F means it is lens formula. Okay. So the magnification there in mirror, the magnification is equal to minus V by U. In lens, the magnification is equal to V by U. Okay. So I can able to directly say that the focal length of a convex lens is positive because the focal length of a concave mirror is negative, right? So it is opposite. The next one, power of a lens. What is meant by the power of a lens? Reciprocal of the focal length is known as power of a lens. So how to write it in the formula? P is equal to 1 by F. What is the SI unit of power? It is diopter. It is not DIOPTR. It is DIOPTRE. What is the symbol of diopter? It is capital D. So this point may be asked in the board exam as a one more question. 1 diopter is equal to 1 meter power minus 1. What is the value of 1 diopter? 1 diopter is equal to 1 meter power minus 1. Okay. I think we have completed the entire physics. Is there any doubts? Please ask it in the comment bar. Case 2. You want case 2, right? Um, this is case study 2. Okay, now listen here carefully. I'm just going to keep the object here beyond 2f1. Okay, this will be a lens. This is beyond 2f1 means I'm going to keep the object beyond back of the center of curvature. Okay, so what will be happen here? We already know that there will be two lines coming from the object. If it is kept at the center means one from the top and one from the bottom. Here the object is kept at the top, so both the lines are come from the top. Okay, one will be directly pass as a parallel line. When a ray of light parallel to the principal axis, it comes back to the focus. This one completed. Next one. So the next one is when a ray of light passes through the optic center of lens, what will happen? It directly pass through it. It will never come back because we are talking about lens. If it is mirror means there will be reflection takes place. Here it will not come back. So when these two rays meet each other means image will be formed here. Okay, image will be formed here. The image is the object is kept at the top, but the image is formed at the downside. So it is inverted. So we already know the nature of the image of a convex lens. It is real and inverted. Whether your doubt is clear? Okay, call your friends and tell them next biology class is going to start at sharp at 6:50. Make a call to your friends, tell them to join the same link. Biology class will start at sharp at 6:50. Okay, now the time is 6:43. Take a break of 5 minutes. Biology class will start at sharp at 6:50. Okay. Good evening, everyone. I think only few are there. Please make a call to your friends, ask them to join the live session. Now we are going to move to the